By evaluating integration through the minimum cut concept, can we explain any enigmatic property of consciousness? So the integration with the minimum cut explains, in essence, why, for example, cerebellum doesn't contribute much to consciousness. And in week 3, I explained that cerebellum, back of the brain here, contains roughly 4 times more neurons, which is like 60 billion neurons, than in cerebellar cortex. So entire cortex has only 20 billion, but it's still huge neurons. The difference comes from the fact that each of the neurons has been really well packed into small areas of the cerebellum, like this one. So this is the mid-sagittal section of the cerebellum, like this way. And then here it is composed of many different kind of folding and so on. And they are packed, and small neurons are there, and then many connections are nicely packaged into these small areas, and that's why we have 4 times more neurons than rest of the cerebral cortex, like this way. And I explained it in a week 3 video already. And in fact, the cerebellar cortex is not that thing that is super simple. Each of the component of neurons is very complicated, and also number of the synapses are in the case of the Purkinje cells, it can be like 10,000 or even more. So from the just complexity kind of idea, it's not that easy to say that this is just simple or easy path, easy system to understand or anything like that. But for some reason, cerebellum has not been shown to contribute a lot to consciousness. And people can be born without cerebellum, and those people turned out to be quite intact in terms of consciousness. So this is, for example, one patient that was reported in 2014 in the journal Brain. And this is a Chinese person who was born without cerebellum, and she was described as relatively slow in terms of the development, in the sense of the speaking, and also walking, moving. And these kind of things are, in fact, the job of the cerebellum. So if you don't have the cerebellum, your way to speak is going to be stuttered, and also the movement also becomes clumsy. But still, she can actually manage to do it, learn through potentially, using cerebellar cortex, cerebellum cortex, right? And in the end, she can catch up with these people, and can go to university, and then work, and also getting married and things like that. But this particular person felt dizzy or some kind of illness, and then went to the hospital at some point, and then got this scanning, PET scanning, MRI scanning, and then only at that point she discovered that she doesn't have a cerebellum. And this is not one isolated finding, but it has been reported in the past as well. And so evaluation of the sensory system of this patient showed no abnormalities. So she doesn't say that she has complete visual field, and then she can experience color and motion and shape and things like that, and the emotion is intact, and that's why she was able to get married, and she raised the kids, everything. So and also personality wise, it also is more or less the same, and things like that. But what is different is the motor system and also language. That is definitely delayed and so on. But inside of the brain, it seems it's quite intact. Now, why this is the case? That's a question, right? So architecture of the cerebellum is, as I mentioned in week 3, there's a lot of neurons packaged and in a very complicated way, but the way it is connected is almost like parallel, many parallel kind of subsystems which doesn't talk to each other. So it's almost like a highly sophisticated pixel of the cell phone or something like that. Each of these unit does a lots of sophisticated timing job or routine and many things. And therefore, many of the things that we do habitually or non-consciously, like moving this hands or moving the tongues to produce each of the sound or group of the sounds to talk about or understand and so on. This kind of timing related coordination is all outsourced into the cerebral circuit. And that can, in a sense, lift the job of the conscious deliberation. It becomes all non-conscious and then performed very well, efficiently. And this is a schematic of one of the IIT papers, but many of the activation coming into cerebellum is in a complicated way, processed in a feed-forward manner to produce optimum timing and procedure, right? But each of the subunit doesn't talk much. And that's why if you consider everything, it becomes very low. But each of them can be relatively complex in itself. The number of the phi or integrated information is computed in IIT version 1 here. So don't worry too much about it. Anyway, so the many neurons form locally parallel circuits. And that is also in a feed-forward manner. And this kind of architecture is actually suited for the precise and unconscious processing. And now coming back to this integrated information, axioms to postulate, right? This is an integration, schematic. And the integration axiom said that consciousness is unified. Each experience is irreducible, cannot be subdivided to non-independent, disjoint subsets of phenomenal distinctions. Thus, I experience a whole visual scene, not the left side of the visual field, independent of the right side, and vice versa. And to support this integration of the conscious experience, there must be physical system that is integrated. That's a sort of the top-down kind of helicopter to summit kind of idea. And the way we formalize it is that evaluating how much a system changes if it's minimally cut. Okay. So in summary, the concept of the integrated information explains why our consciousness is intact even if we have no cerebellum. And IIT proceeds from level, boundary, and contents. And so far, I've been already, kind of explained the level and boundary. And the contents will be the next week. So what is the IIT's, proposal about boundary of consciousness? That's the next question.